our first of those talks is going to be given by Dr. Noah Petro, and it's on the Lunar Reconnaissance orbiter in the age of Artemis and CLPS. So Noah, take it away, please.
All right, great. Well, thank you so much, Greg and Manesh. I appreciate being in my basement with all of you today. Welcome. And of course, today is a day we look back and we also look forward. And looking back 52 years ago at this moment, the Apollo 11 crew is in the 11th of their 31 orbits. Shortly, the crew would separate, and Buzz Aldrin and Neil Armstrong would make their way down to the lunar surface. And so as we look back on what we accomplished, we also can take a moment to look at what we're doing right now. And this is the quick map view of the moon. And what we're seeing is, of course, LRO is currently orbiting the moon. LRO is flying over the lunar far side right now, right along the terminator, and about to pass over Mare Moscoviense. And so if you allow me now to transition gradually over to my presentation, what I'd like to do is talk a little bit about the future of LRO. Where are we going? And a little bit of where we are in terms of the status of the spacecraft. And so, of course, July 20th is an auspicious day in exploration. And what we've done now at every lunar science and now an exploration science forum is have an opportunity to talk a little bit about what we're doing with the spacecraft, what we're doing with LRO. LRO is nominal. NASA speak for everything's going well. The last year has been remarkably challenging, and the LRO team, both the engineering team, the science teams, have met the challenge exceptionally well. Since March of last year, we have effectively had a small core group of people who have occupied the operations center at NASA Goddard. And the rest of us have been working remotely 100% of the time. LRO was not designed to be operated in this manner. And of course, we met the challenge. Incidentally, in my presentation today, I'll have kind of in the old school LPSC style, one half of my slide talking about the points I want to make. And for those that want to listen with one ear and pay attention with their eyes, some recent highlights from LRO, because as much as we've all changed, the science results from LRO continue marching on. One point I did want to make about how we operate the spacecraft during a pandemic is that, it's not just the operations team at Goddard or the science team scattered around the world. It's also the ground network, the stations around the world that have continued to operate under remarkable challenges. And what I've become amazed by is during the worst portions of the pandemic, the Deep Space Network station in Madrid continued to operate. It was nothing short of a miracle, I think, that the entire endeavor continued on. Our White Sands antenna in New Mexico, our one link to get data down from the spacecraft, has continued on. We've learned how fragile this Earth is, and the networks that we rely on are during the pandemic, and that network has remained strong. In May of this year, we had a lunar eclipse. It was our first total lunar eclipse since January of 2019. LRO, as we've done a number of times, went through power-reducing operations. We did keep Diviner on to continue to make thermal measurements of the surface to record the cooling of the lunar surface during the eclipse. It was an exciting observation that we were able to do because we have a robust system that we monitor quite closely. Right now, we're in preparation for our next extended science mission proposal. It's due January 18th of next year. And this proposal would cover us from September of 2022 through September of 2025. Right now, LRO has about 15 kilograms of useful fuel on our spacecraft. Depending on our use of that fuel over the next several years, those include things as phasing our orbit for eclipses, changing our orbit to be in a better position for science observations. We have as much as 7 years of fuel to use ahead of us. Currently, our inclination, that is our tilt away from the pole, is at about 85.5 degrees. And so this means that we will gradually continue to move away from the pole over the course of our next extended science mission. What this does is densify our coverage over the South Pole, and that coverage continues to take us over the so-called Artemis zone of 84 degrees and poleward, letting us build an incredibly robust data set, allowing us, as Jim alluded to understand this remarkable polar environment. As you'll hear in the next set of talks in this session, the future of lunar exploration is remarkable. We have a number of lunar missions that are coming to join LRO in orbit at the moon, as well as obviously missions to the lunar surface. And so this next fleet of missions to the moon joins the recent flurry of activity at the lunar surface. And I take great pride in that LRO has been there for the duration of this sort of renaissance of lunar exploration. Our data and our observations become this thread of understanding all of the data sets. The one unifying factor apart from the moon is the coincident observations of LRO. Whether it's the understanding of the dynamics of the lunar exosphere or the radiation environment, LRO provides this baseline for observations with the rest of the mission. As I said before, we are preparing our next extended science mission proposal. We have five main themes following the science themes of volatiles and external interactions. That part of the proposal is being led by Angela Stickle. Regolith and cratering on the lunar surface being led by Catherine Elder. Volcanism in the lunar interior by Julie Stopar. And our support of missions, identifying landing site, characterizing the lunar surface for these missions being led by Maria Banks and John Keller. And so this new era of LRO is partnered with this new era of lunar exploration, and one that I'm particularly excited to look forward to. This morning, we all witnessed something quite remarkable occur out in West Texas. And so I actually changed the quote that was at the top of my slide here. This new era of exploration, I think, is one that obviously we are excited to be part of as scientists and as engineers. But we also look for others to join us in this new era of exploration. And the next decade of lunar exploration is going to be incredibly profound in its terms of discovery and the excitement. And so I encourage everyone to participate in any opportunity to communicate that excitement to the public, particularly through International Observer the Moon Night later this year in October. Later this month will mark 50 years of exploration since Apollo 15. And that moment of science and exploration joined together is one that I hope that LRO continues that proud legacy and over the next many years to come. With that, I'll conclude and have time for questions, or can transition to the next speaker. Thank you.
Noah, thank you so much. And it's hard to imagine doing what we're doing now, progressing towards Artemis and moving towards CLPS just later this year without LRO and all the absolutely amazing science that it's given our community. So I know on behalf of everyone here, thank you very, very much for your leadership and your team's contributions. It's just been absolutely fantastic. So I think that with that, what I'm going to do is just progress on to the next speaker. If I could ask you and the others to hang on, and then we'll take questions at the end of the session.